guys, welcome back to the discussion for quiz. So this week quiz we are going to discuss on thermochemistry. Altogether, we have 5 questions for your quiz. So we are going to start with question number 1, follow on to question number 2 and so on and so forth. So let's get started. So question number 1. Determine the specific heat of a sample of copper from the fact that 64.0 joule are needed to raise the temperature of 15 gram of copper metal from 22 degrees Celsius to 33 degrees Celsius. So, in the question, you were asked to calculate the specific heat. So, the formula that you need to use is Q equivalent to C delta T. Right. So T is the temperature, C is the specific heat, or the C is the specific heat, but this one you need to convert to S later on. So we are going to calculate the C before you can get to the S. So from the question, 64.0 joule are needed to raise the temperature of 15 gram. Okay, so from 22 degrees Celsius to 33 degrees Celsius. So your Q should be 64.0. Your C is the one that you want to calculate. So delta T, what is delta T? Delta T is the final temperature minus initial temperature. So final temperature minus initial temperature. So you will get C equivalent to 64.0 divided by 11. So your C shall be 5.8181 joule over degree Celsius. Because this one is in joule, this one is degree Celsius. So this is the value of C. So from C, you need to calculate the specific heat. So specific heat is S. So C equivalent to MS, right? So since you know the value of C, so we can say that 5.8181 is equivalent to M. So what is M? M is the mass. So the mass of the copper is 15 gram. So 15. So your S. So your S is equivalent to 5.8181 divided by 15. So you should get the specific heat for this question is equivalent to 0.379 joule over degree Celsius, and then gram. Okay. Moving on to question number 2. A 50 gram sample of water at 100 degrees Celsius was placed in an insulated cup. Then 25.3 grams of zinc at 25 degrees Celsius was added to the water. The temperature of water dropped to 96.68 degrees Celsius. So determine the specific heat for zinc when the specific heat of water is 4.184 joule over gram degree Celsius. Alright, so how are you going to do this? So you have 2 different things, which is water and also your metal, which is zinc. So you need to remember that energy cannot be formed and it cannot be destroyed. So it means that each and every substance in this reaction will have their own Q. So Q plus Q equivalent to 0. So because you have Q for water and Q for zinc, so you will be Q equivalent to MS delta T plus MS delta T equivalent to 0. Right. So M, the mass of water is 50 gram. So I'm just going to label here. So this one is for H2O, this one is for zinc. Okay, the mass for water is 50 gram. Given that the specific heat of water is 4.184. So 4.184. The temperature. Initially, the temperature is 100 degrees Celsius. When you add the zinc, the temperature goes to 96.68. So the changes of temperature is always final temperature minus initial temperature. So it would be like 96.68 minus 100. Okay, this one is for H2O. Since that I'm going to calculate the value of S for the zinc, I'm just going to move this over there. So it's going to be minus here, the whole thing. The mass of the zinc is 25.3 gram. S is the one that we want to calculate. And then the zinc initially is at 25 degrees Celsius, and then at equilibrium it turns into 96.68. So it minus the initial temperature is 25. Alright, so basically what you will get is this one. If you calculate it, you should get negative 694.544. So it's equivalent to, because this one is negative, right? And then your answer here should be negative 18,1813.504 S, right? Because you are going to calculate this S. Okay, so you're going to bring this over here to make it easier, because this is negative and negative, you can slash this both. So you will have 1813.504 S is equivalent to 694.544. So your S shall be 694.544 divided by 1813.504. So you should get your S equivalent to 0.3829 joule over gram degree Celsius. Right. So for this, this is your final answer. So for this chapter, if you don't write the unit, so your final answer doesn't count. So make sure that you write the correct unit for the S. Moving on to question number 3. How much work in joule is done when a piston expands from a volume of 13.27 liter to 76.55 liter against a pressure of 14.89 atm? So this is a rather straightforward question, because the question already asks work, right? So work, there's no other formula that you can use. So W is equivalent to negative P delta V. Right. So what is the pressure? So given here, the pressure is 14.89 atm. So negative 14.89 atm times changes of volume. Always take the final volume minus the initial volume. So 76.55 minus 13.27. So you should get your work equivalent to 942.2392 liter atm. Okay, but look at the question again. How much work in joules? Okay, don't forget to convert this value to joule. So 1 liter ATM is equivalent to 101.3 joule. Okay. Therefore, if you have this value 942.2392, so you should get 101.3 times 942.2392, so equivalent to 95448.8309 joule. Okay, this is your final answer for the third question.